Okay, I'll start my talk. So hi everyone, welcome to Resummit. Today I'm going to introduce Ray Workflow. Ray Workflow is a new library in Ray that gives Ray tasks with durability. With Ray Workflow, you can construct durable, efficient, and flexible data pipelines. Ray Workflow will alpha release in Ray 2.0. About myself, I'm currently a UC Berkeley PhD student. I intend in any scale during summer for the Workflow project. And Ray Workflow actually is also related to one of my research projects on Workflow systems. So this is the outline of my talk. So first thing, why we need Ray Workflow. So Ray Workflow is Ray plus Workflow system. To understand why we need it, we first need to understand the pain point from Ray and a typical workflow system. For Ray, let's just look at a simple example. Here, you define a simple Ray task and execute it. The output of this task is stored in memory. That's good because it's very efficient, but also because memory is volatile, so you have durability issues. It means that after completion of this task, you may lose this memory in the future due to some system failure. Another thing issue about Ray Task API is that it is not declarative. For example, when you try to execute a task, you will execute eagerly. This is good for some applications which needs this kind of ego execution, but it also results some problem. For example, you want to check inspect the task or some properties or make a plot before executing the task. That's generally very hard to do because the task will execute as you trigger it. And there are also some pain points for workflow systems. The first thing is that these workflow systems are not born for distributed tasks, so they naturally have some scalable and data transfer efficient issues. For example, a typical workflow system they cannot pass some large objects like a large data frame or some very general Python objects like a Python lambda function between different workflow tasks. So what they really do is they define some scripts and run each workflow task inside the script. And each script at the end of each script, it saves something in the file system. And in the beginning of the next script, it tries to know something from the file system. So there's clearly some efficiency issues in data transfer and scalability. Also, some existing typical workflow systems are also limited by programmability in general. For example, in some workflow system, you can only define your workflow for your application as a YAML file. Basically, everything is static and fixed. So this makes it cumbersome if you want to build something more complex and dynamic. So here are the pain points of both sides. So Ray Workflow combines both sides, and our hope is that by combining both Ray and the Ray Workflow and the workflow system, we can combine the benefits and addressing the pain points from both sides. So let's look at a concrete example about how it works. So this example is in this example we'll build an end-to-end ML pipeline with a story. The plot of the story is very simple. So upon a time, 3 engineers try to build an end-to-end ML pipeline as a hackathon project. So they want to do that quick, and it's a prototype. So, and each of these engineers would investigate a different framework for the pipeline, and later they will pick up a single framework to build the actual pipeline. So here, let's start with some workflow systems like Airflow, Metaflow, etc. And both prototypes directly with Ray, and just gives Ray Workflow a try. So the first step of building ML pipeline, because we want to start from something very simple, so we just start with a very simple pipeline. This pipeline basically just read some data from a storage and do some pre-processing and train with the process data, and finally solve the data, solve the train model. And first thing I noticed that actually for each stage of the pipeline, it requires different hardwares. And for example, training you need GPUs, pre-processing you need CPUs, and deploying you may need both devices depending on latency and the throughput choice. So, and this device could place in different places, so it places in different machines and locations. So it's actually a distributed pipeline. And the issue when I try to build this workflow to implement this simple pipeline with the workflow system is that most workflow systems are not equipped with a distributed backend. So I had to set up by herself. For example, I may choose some very popular combination. This combination contains like Airflow and Celery executor, where Airflow is the workflow itself, and the Celery is for distributed execution and orchestration. And she needs to configure a lot of stuff like a scheduler, the dashboard, the worker nodes, etc. And I also encountered some challenges when I try to stitching multiple pipelines, multiple tasks in this pipeline, because for example, in Airflow, there's no mechanism for like passing large or general objects between tasks. For example, like after pre-processing, you generate a huge data frame, and you cannot say that I just pass that with cross communication. Yeah, because actually in the doc Airflow that says is something not good. While I'm still busy with the configuration with the workflow system, let's say what's Bob going on with Ray. So Bob uses Ray because Ray is an open source unified distributed framework for scalable computing, and Ray is also capable or very good at passing large and general objects inside the distributed system and do scaling, etc. So it's not hard to actually provide this pipeline with Ray. So for example, all we can do is define a retask, and for example here is a retask for pre-processing, and we invoke this process retask with input data, and this retask will return a feature of the object immediately, and then we can pass like the returned object ref, the feature, into another task, and so on. And by chaining it together, you get a pipeline. But choosing Ray because like something like a Ray AI runtime contains some scalable integrations with best-of-breed libraries and ML toys. So if Bob want to scale up later with this prototype, Bob is very confident because, for example, you can possibly like instead of using a simple retask, you can pre-process the data with Ray data. You can do some training with retrain and serving with reserve, and you can extend this pipeline into a scalable pipeline. So what's on the Charles side? So Charles learns that when you use Ray workflow, actually you don't need to change your Ray code. So basically, Charles could just bring like a both code here, but you still need to do something different. What you need to do is basically replace the remote here with something called bind when called retask. So why you use bind? It's because when you build a pipeline with remote, retask, as we explained before, retask will be executed eagerly and returns the future. So if like here just want to have a pipeline and first, and maybe just want to do some checking and validation and visualization before running it, and if you just run with ego tasks, it's very hard. But if you bind them first and execute that later, then it wouldn't be an issue. So here, like by replace .remote with bind, basically this task will not be executed immediately. It will be a lazy execution. So you can actually get a structure of the pipeline. You can do like you can perform some visualization, or you can validate the pipeline and then you execute this pipeline. So for summary here for this simple initial task is that when you use workflow, I have some difficulties because like when you use workflow system to implement this distributed task, workflow is not designed for distributed tasks, and it's also not clear how to scale that pipeline in the future. And if you just build the distributed pipeline with Ray, yes, you are scalable and efficient and easy to build. But the Ray task API is not declarative. It will be executed eagerly, and yeah, it's not good for something like validation and execution before validation and visualization before execution. And with real flow, you can define a workflow by a declarative API, and the workflow will be running distributed in a distributed way by Ray. So the second step is to, we have simple pipeline initially, and we want to extend this pipeline. So when this extension will be done by adding, for example, adding some validation step. It's not for the pipeline, it's for the trained model, right? How could you deploy a model without validation first, right? So that makes the pipeline more complex, and you can adding more steps, more for tasks like this. And at this stage, like basically Alice and Bob, they argue for different stuff. So Alice actually argues for durability, and Bob argues for efficiency. For this thing, for example, I think like durability will be an issue for this complex pipeline, and Bob thinks actually efficiency will be an issue for this complex pipeline. And let's see why. So in Ice's point, if because Ice is using a workflow system, if a task failed in a workflow system, you only need to rerun the failed task. Because the output of the previous task is already checkpointed in a workflow system, so the task output is durable. But because Ray tasks are stored in memory, it's not durable. So you by default you don't have this kind of checkpoints. So during running or recovering the pipeline, the output in the memory may lost, and Ray has to recover this previously completed task if the output object is lost. So what's worse, because you cannot predict that which parts of your memory will be lost, right? These things could have happened in random. So the recovery will be in dysmetric. You may, for example, maybe all outputs of all tasks are lost. You just start from the beginning, or maybe like the output of training task is lost. You just need to recover and rerun the train step. So that makes another thing like in dysmetric, and but this shouldn't be a problem for workflow system. So without because workflow systems, the benefits of workflow system is that it supports something like a deterministic recovery by checkpointing. Without workflow system, Iris worries that as the pipeline gets more complicated, you could have more frequent like in dismiss recovery, and this will result in some unexpected effects, and the total execution duration will be highly unstable. And Ice is also worries that if some components in Ray fails, like for example the Ray head node, or like or some key component in Ray fails, basically like Ray cannot recover by its own because everything in Ray is running in memory, and you need to reboot the whole pipeline, which is not the case for workflow system, because you can just restart workflow system and load the checkpoints and start from the checkpoints. However, compared to Bob is using Ray, and Bob is actually more interested in efficiency. Bob points out that there will be more data transfer happening in a more complex pipeline, and more complex and distributed pipeline, right? As get complex, there are more data passing between steps. So data transfer is actually, data transfer actually is an important topic for end-to-end efficiency. Compared to a workflow system, really heavily optimized for efficient data transfer. For example, Ray has a lot of mechanisms like shared memory, zero copy deceleration, distributed scaling, which will make you like data transfer and scaling between these tasks very efficient and fast. When you use a workflow system, not only like this inefficient data transfer, checkpointing to storage alone would be a bottleneck because you only like a checkpoint, write something to this will be slower than you schedule a task or passing a task through network, so this will be a bottleneck for an end-to-end system. So while like Ice and Bob are debating, how about workflow? Let's see how Charles thinks. So when Charles look into real workflow, actually real workflow could overlap like scheduling, data transfer, and the deceleration with checkpointing. So yes, real workflow checkpoints like a workflow system, and real workflow do data transfer efficiently like Ray. And the workflow actually will parallelize and overlap this both checkpointing and the data transfer. So either data transfer or checkpoint will not be the bottleneck of each other between these workflow tasks. And besides this, real workflow could also enable something like optional checkpointing, like skipping checkpointing. If you find like a checkpointing is not necessary and will be a bottleneck in your system, you can just skip it. So you will run as efficient as Ray. You just have like a data transfer empowered by Ray. So we will see why this will be very helpful in the next example. So this conclusion of this part, we can see that by making the pipeline more complex, a typical workflow system has some efficient data transfer problem. Because there are more data transfer happening in the more complex pipeline end to end, and the durability really becomes an issue in a very complex pipeline. Because as it gets more complicated, then failure could happen. You will get a higher chance of failure happening, and the recovery will be very random. And with real flow, you have both you can be both durable, make your pipeline both durable and efficient. Yeah, and the next they want to further extend their pipeline. So while this is where workflow shows its true power. So the previous example all assumes that data will not evolve. So you have a static database or storage, and the data you have a static like training pipeline. However, nowadays, like data generation are faster and faster. It's very safe to say that most data stays in the future. This makes like online training unnecessary. It will be just a difference. The difference will be like how often you would like to retrain your model with the new coming data. So online training will require both the coming new data and some old data. So another and trivial approach is to just add another data processing in this pipeline. But there's one more efficient approach here. So basically, the other side is like a pipeline running previously, right? Because you may already execute a pipeline on the old data. So why not just borrow some data from the old pipeline instead of running data processing again? So this part like by using the data from the old pipeline, you skip data processing, and you also training. You are also training not from scratch, but from a training checkpoint. That also both strategy of training, and we can actually repeat it like for all pipelines. Yeah, you can see it will create like basically this new pipeline with the new data like borrows some old pre-processed data and borrows the train model from a previous pipeline, and it further borrows the previous pipeline further borrows some like train processed data and the model from the even older pipeline, and so on. So these are some interesting consequences. First, like durability become a must because now you have a very long dependency chain, and it's extremely expensive to recover if something fails. Like basically, if something fails here, and you try to recover this very long chain, you need to do a lot of rounds of training, And the second, skill checkpointing becomes really helpful here because when we are trying to concat data from previously data from the new coming data and the old data, it just concat data, right? There's no need to checkpoint this concat data. It's very simple and efficient to concat it again if this step failed. And yeah, what you can do is like basically specify an option here. Like yeah, for detail, you can look into our doc. Yeah, to basically skill checkpointing for this concat workflow task. And third, like assessing the task of the output of previous workflow actually creates a dynamic dependency. This is because depending on how fast the new data comes, the previous workflow could still be running, right? The new data comes very fast, like with old data at the same time. The old pipeline may still be running, or the old pipeline already finishes, or you could add any like status, unknown status. So it's something like so basically you need to dynamically create some like dependency between the new pipeline for the coming new data and the old pipeline of the old data. So what you can do is like in our current workflow API, we have something like a get output async. Like basically you can with the previous workflow ID and the task name. Like for example, here like you want to get a training output based on the model. You can specify the workflow ID of a previous pipeline, and the task ID is the ID of the previous training task. And this is how you could create a dynamic dependency between different workflows and different pipelines. So here, like we can see in this online training task, if you are working with typical workflow system, the first thing like a lot of them they are not actually support something like skill checkpointing, and also. They cannot create something like a dynamic dependency. Say that I want to create something dynamically whether the previous pipeline workflow is still running or finished or this kind of stuff. And there's some issue. The durability is still issue for Ray, and it's become more serious here because you have an even longer dependency chain, and not durable is really a downside. And with RealFlow, you can skill checkpointing, and you also guarantee durability, and also you can build something like dynamic dependency between workflows and tasks. So the finally like the example is to we want to further extend it for real world production. So in real world production, it doesn't make sense to deploy your model directly after validation. For example, even you say that I validate the trained model, but the data distribution of the real world could be different from the data distribution of the model, the data you are feeding in, right? So instead we can try to roll out the model slowly to more and more users. For example, you first roll out 1%, roll out this model to 1% of users, and 10%, and 100%, and during rollout. If you detect something that's wrong, basically like this raw model is very bad, you can choose to roll back your rollout and maybe using like the previous model. So to support this kind of rollback, you need to support some kind of dynamicity because you just will not, after the rollout, you will not know beforehand that whether it will be success or not. So you also don't know whether you will continue roll out or you will just roll back after this like a roll process. And currently, like due to because of some workflow systems like could just define like the workflow in a template like YAML file, and this kind of dynamic is limited. So, but unfortunately with Ray workflow, but also with Ray is very good at like implementing something like this because Ray is very dynamic and flexible workloads, and fortunately with Ray workflow you can inherit this kind of dynamicity. So Ray workflow does not only support this dynamic workflow tasks, and even for this, and it also guarantees the durability for this when you're programming this dynamic task. So here we can see the pseudocode for this rollout. So what you do here is like you just write a normal read task, and here you have a percentage for rollout. In this task you call deploy rollout to make that rollout, and you then after rollout you will check like whether the metrics is good. If say the metric is very bad, like rollout fail, is prone to be failure, then you will call like a workflow. You'll just like return like a rollbacks, basically rollback task from a workflow. This makes the workflow know that okay, you will dynamically run rollback after this rollout. And if the percentage is like over 100, it basically means that the model is fully rolled. Then you just return. This makes the workflow know that okay, the workflow is terminated. And else, if you find the routes are okay, you want to further increase the route, so you like 10 times your route percentage and return that route task. This will tell real workflow to append a new route task after the previous task dynamically. So this is kind of how we are supporting dynamicity in our workflow system. So here's the summary. Like with dynamic rollout, if you are using a typical workflow system, it does not support something like dynamic task generation, and also it makes I know some workflow systems actually could generate some very dynamic tasks, but it does not guarantee the durability of this dynamically generated task. And same here, like array is not durable, and but with workflow you can have both dynamic and durable workflow. So here's the summary. It's basically the copy of the first table. And then we can just arrange this a bit to see like it actually faces these pain points we listed before. Like for example, for workflow, it is not bound for scalability for distributed tasks, and you also limited in programmability. And with Ray, the task API is not declarative, and they are not durable. And these four tasks actually, these four attempts to build a pipeline and extending it actually shows actually proves like these pain points, and also shows like real workflow is capable of solving these pain points. So what's about the future of real workflow? So workflow is still in alpha stage, so you can try that. It's very interesting and fun project I have ever done, and but still at a very early stage. So for next step, I'm considering like trying to integrate this with REL and reserve, because for example with REL you can guarantee some durable training like at scale, and reserve you can guarantee something like a high availability serving. And we will try to continue trying to integrate with third-party libraries. For example, we will integrate with Jupyter Notebook, like making like Jupyter Notebook like durable. That's very interesting. Thinking like if maybe some people are playing with like Colab, like Google Colab, and if your Colab is like it's turned off or something happened, you can still running from a checkpoint. And we also try to integrate with the salary, and with some new projects like NinaPy, etc. And we welcome for some future requests and collaboration in like GitHub. So and last thing, if you want to show some real use cases, because I just show like basically something. Try to prototype something, right? You can see there's a IBM Summit talk tomorrow. It's Wednesday and at 2:45 p.m. So you can also scan this like QR code. You can see how IBM builds a unified pipeline to evaluate multitask non-grid models with real workflow. So finally, thank you for listening my talk, and you can contact me with my email, and you can scan this QR code. It's point to our latest workflow docs. and welcome for trying Ray Workflow. And yeah, maybe you can also have ask some questions. It's Q&A.
Yeah, thank you. Great presentation. And I have a question about, you talk about efficiency and performance. So do you have done benchmarks against like other systems like Airflow and so on? And my second question is about the collaboration. So you talk about like linear pi, what kind of integration are you looking for?
Yeah, so the first thing, I did already done some benchmark here, like with some ML ops like example from like for example like from Azure, like there's Azure like ML ops example with some workflow systems, and here we did have some advantage because like I've already shown like basically I think already here is like workflow is based on Ray. So Ray already provides some like efficient data transfer that's not every workflow system could have. For example, in the original ML pipeline, when they like preface the data set, what they have to do is they basically have to dump like the output to S3 storage, and something because every state is running with a script, and you basically without help of a different system like Ray, it's not so simple to like passing data between different tasks like in a seamless way. So like we have a advantage because of like more efficient data transfer, and sometimes also because of like because of dynamicity, because you can see like the dynamicity is actually integrated inside our system. We have like use something called workflow configuration. Basically, you can return like a workflow task inside the workflow task to to append something, append the workflow task dynamically with some other workflow systems. Like for example, as Airflow suggests, you have to basically generate like write a Python script file in your file system, and this actually has also makes this sometimes inefficient. Yeah, and by the integration with NiaPy, currently NiaPy is trying to NiaPy is I think it's great like a great project trying to bring like bring data scientists when working with some Jupyter notebook, making that Jupyter notebook turning into a production pipeline. And what workflow could help here is like basically you can, for example, NiaPy could destroy this pipeline with Ray workflow. So this workflow can be running like distributed and durably with Ray workflow, and yeah, that's something. Yeah, that's also it can be enhanced by something like later, for example, with ReL and return some this kind of library. So that could make like NiaPy both more efficient and scalable.
Hey, can you hear me? Okay. Is it possible to register Ray workflows and then invoke them through an API call in maybe something like an Airflow task? So I have like an Airflow job, it needs to run on all these different computers, and then the next step would be pass the results to a Ray workflow.
Yeah, so something very good about Ray workflow is like basically like when you use the workflow, you just change something like from like remote to bind. If you listen to maybe the result, it's actually using the Ray API. So basically everything you can do with Ray is also you can also do with Ray workflow. For example, like in your case, I can imagine that you can like with Ray you can just call read init and maybe or in a like Airflow like step you can Airflow task you can like run a remote task. So you can also do similar things with Ray workflow. And besides, you can also do something in reverse. Actually, in workflow, you are able to run some Ray tasks, like no workflow task, Ray tasks, and we will automatically checkpointing this Ray task, like when you're returning this Ray task from a workflow step, or you are passing some Ray task to a Ray workflow step. So we already have some integration with like with Ray. Yeah.
We'll take one more question. So one thing I was curious about, so within each of the tasks in the workflow, they have different resource requirements.
Yep.
So is this assuming that we have like one Ray cluster at the minimum that's running for the length of the pipeline? Like it seems to, like I think this is really cool, but I'm wondering like, is that kind of become an issue where you're not utilizing your resources efficiently because you have all these resources in the Ray cluster, but different tasks need different resources, whereas if you have like something like Airflow, each task could kind of like be requesting the resources that it needs and maybe provisioning like a separate Ray cluster where you just have whatever you need. So I don't know if you have thoughts on that or if I'm understanding correctly.
Yeah, so actually that's a good question. So yes, currently like Ray workflow could only work with a Ray cluster. That's also also makes sense because like it's backended by Ray and Ray is a different framework, and yeah. But I think that's for two things. Like first, like because Ray has auto scaler, basically Ray can auto scaling. So actually with a single Ray cluster, you can do something similar. Like for example, initially this Ray cluster doesn't have like GPU workers. But with real autoscaler, when Ray workflow requires some GPU resources, Ray will like actually provision basically like a GPU node. Yeah, and also like I'm also interested to further extend Ray workflow. That's also like some future plan. What I'm trying to do is like extend it to multiple clusters and even multiple clouds. Because I say like because I think it's most real value I feel is like you can. Workflow can help you like migrate like different your tasks between classes and between clouds because everything is like basically like trip pointed. You can just like for example you can run something in another cluster or another cloud and you can just like bring the trip pointed data from a previous running cluster. Yeah.
Yeah. If anyone else has other questions, we can take them offline. Oh. Do you want to take it offline, actually? We're at the end of time.
Yeah. Oh, yeah. Thank you, everyone. Yeah.